So there's a story about a boy who goes to the circus with his father, and they come across an elephant that's tied up with a small rope. And the boy asks his father, how can it be that this huge elephant that's so strong and powerful is being held in place by just that thin rope and a small stake? And his dad explains to him that when the elephant was young, was a baby, it was tied to the stake with something much stronger, a chain that it couldn't break. And so the elephant would pull on the stake and wouldn't get away. And so in its mind, it thought, okay, I can't break this chain. So as the elephant grew up, the circus owners were able to switch the chain for a small rope. And because the elephant was already programmed in its mind that it couldn't break away from the stake that was holding it, it gave up trying. And so from then on, the elephant could always be held in place just by a simple thread. So I'm telling the story because I think it applies to our current version of pi, and how we all apply the knowledge that we obtained about pi from elementary school, that it's this very important number, which it is, but the version that we know, the base 10 version, we think is the only version of pi. We equate the number of 3.14195 as it goes on. We equate that number with pi without thinking of perhaps there being another version in another base that may actually also have different qualities. We just naturally assume that all the qualities of pi, the base 10 version of pi, are the only qualities that exist, and it doesn't make any difference which base we approach pi in, this concept of dividing the circumference of a circle by its diameter. So I would question that and say, well, perhaps there are differences with the different base when we look at this ratio, and there may be things that we can find out by exploring pi in a different base that we don't really know until we actually try it. Otherwise, we're just assuming something without actual proof. So I've been exploring the idea of base 12 pi for the last 5 years now, and I discovered there is a significant difference between base 10 and base 12 geometry. It lies in the division of the 1. Usually we think about counting in groups of 10 or 12, but it's in the dividing of the 1 into tenths or twelfths that we actually create smaller units or different sized units. So the Cartesian plane in base 12, all the lattice points are different distances from each other. So any decimal places that we are using in base 12 are actual different sized units that we weren't using in base 10. So that's something to consider. And what happens is that there's a geometric pattern that emerges in base 12 that has a relationship to the 1 that we don't see in base 10 because it just doesn't work out that way. And this geometric pattern, it's a type of dodecagon, you can see it here behind me now, gives us access to the geometry of the circle that we don't have in base 10. There actually is no geometry of the circle, and we don't even realize it. We don't know what we don't know about pi in base 12 because we simply haven't explored that option or venue or that direction in math. So there is a geometric pattern that we can approach pi and the circle in base 12 that gives us the ability to actually plot all the points that define the circle. Basically, we can build a number line for the circle in base 12 that we can't do in base 10. So 360 degrees is a part of that. Currently, there's no way to actually plot all 360 points in base 10. It just doesn't exist. It's something that nobody really talks about. Who likes to talk about things that we don't know? But this is a fact. Nobody knows how to actually generate all those points on the circle in base 10. Again, using this dodecagon geometry, we can do it in base 12, and that's actually the first step that I show you in the journey towards understanding the base 12 version of pi, is to show you how to actually construct a diagram that generates all 360 degrees. So this is the subject that I'm exploring on my YouTube channel, Duodecimal Division. You can go there and you can find a whole bunch of videos explaining the difference between base 10 and base 12, the base 12 dodecagon, how it relates to pi, what the base 12 version of pi is, why it's different, the different characteristics it has from the base 10 version, why it's important, and also the fact, surprisingly, that somebody already knew this a long time ago, that people or culture that came up with 360 degrees had to do it using base 12 because there's no other way. And they were also responsible for creating our numerals. So that's another aspect to all this. Our actual numerals, the numbers from 1 to 9 plus 2 more because we're in base 12, were created by somebody using base 12 geometry. So all this information you can find on my YouTube channel, so I hope you can go there and check it out. I'm looking for healthy skeptics with an open mind who are willing to engage in this idea of a different version of pi in base 12. Really look at it, and if you can't find anything wrong with it, which I don't think you will, perhaps we can build on this knowledge and come up with new ways of looking at the geometry of the circle. Okay, so thanks for watching, and I hope to see you in the next videos.